Welcome to the benefits of the BOXX workflow, overclocking and offloading. In this video, I'll explain the concepts behind the BOXX workflow and help you understand the compute requirements of your software. 3D applications like Maya, 3ds Max, or Cinema 4D employ a variety of tools and features, each with their own distinct compute requirements. Although I'll be using 3D Studio Max in this example, the concept of offloading CPU-intensive tasks, whether it's rendering or simulation, would apply to other applications like Revit or SolidWorks. These compute requirements can be broken down into two main categories: single-threaded tasks and multi-threaded tasks. Single-threaded tasks will benefit from a high-frequency CPU, while multi-threaded tasks like rendering will benefit from many CPU cores. The BOXX workflow properly addresses these specific bottlenecks with a unique hardware solution package designed to maximize your creative productivity. Let's take a look at some examples. Tasks like modeling, animating, texturing, and general scene interaction are predominantly single-threaded. This means that increasing the number of CPU cores will not improve productivity. For these types of tasks, you want the fastest CPU clock speed available. BOXX overclocked workstations offer the fastest CPU clock speeds on the market. This enables you to work at peak productivity. To illustrate the lack of a graphics card bottleneck, here you can see we're only taxing the card to about 50% of full load. A more advanced graphics card would not improve the viewport frame rate because the graphics card is waiting on information from the CPU. We can clearly see the benefits an overclocked CPU has on viewport interactivity. When operating at the overclocked 4.5 GHz, the viewport frame rate increased by 30%. Rendering, on the other hand, is a highly multi-threaded process. The more CPU cores you have at your disposal, the shorter your render times will be. However, you do not want to render on your local production workstation, and here's why. As we discussed earlier, low frame rates inhibit your ability to create, interact, and manipulate 3D meshes in your scenes. In this clip, we're getting about 17 frames per second in the viewport. Now let's see what happens when we try to render and work on the same machine. I'm using the local machine as a slave for network rendering. Here you can see all the CPUs being pegged at 100%. When we play back the same clip from earlier, you can see our frame rate has dropped to 6 frames per second. By offloading compute-intensive rendering to the Render Pro, your viewport frame rates will remain high, and you can stay productive in all areas of your workflow.